case we want to import and pattern geometries which are larger than our piezo scanner range, which is around 60 square micron, we need to split the geometries. The non-freezer has a stiction functionality. One is what we call the standard stitching, and the other is the active field stitching. We have other videos that will discuss this more in detail. But in general, you can see that here, when you have a geometry which is clearly larger than our piezo scanner, we can split it only, and we cannot add the geometry in the importer to the layout. So we have to split the geometry. That's the only thing that we can do because the pattern is grayed out, and we see that the geometry is automatically split in the lowest number of cells possible. If we want to change the way these cells are split, we can change the field cell size, for example. If we want slightly smaller sizes, say 45 in X and 53 in Y, we split it again, and we see that now we have a different number of cells and different dimensions. When we split in multiple cells, we can also change the overlap between each cell. So as you see here, we have an overlap between the cell and the above one. So we can change the overlap in both X. So we want 3 microns in X, and we want 6 microns in Y, just as an example, which is clearly visible. So now we see that this field is basically completely within the overlap, and here it's more easily seen the overlap in both the dimensions. We can also change for each field the offset, the read margin, and the read upsampling, and the pixel time for actually all, in this case, all these fields. And once we're happy with our geometry, we can import it as a new layout. In this case, we're importing it as TSPL, but we can also import it with laser. Let's say we put a reasonable pixel size for the laser. We can change the field size, for example, and we have a different splitting, and we change power to 100. So in this case, we see that we have a quite large amount of fields, 106 fields. Maybe we can reduce the geometry, we don't need it so large, so put a scaling here, 0.3. Now the geometry is a little bit smaller, and you see that with the laser we should be able to write quite fast. Again, once we're happy, we import it in the new layout. So once we import geometry which consisted of multiple fields, we can open our drop-down menu, the Advanced Tools, and the Field Editor. The Field Editor is a very useful tool to further edit the fields in our layouts, and it's especially effective in layouts which have multiple fields, of course. So we can open, for example, our last TSPL layout that we imported, and we can see that we can control every field. So in this case we have field 3, or we can select multiple fields. Let's say we want to operate on field 5, which is this field. We can delete it. We can change some read functionality, some transformation. Here we have actually some slight visual bugs, but it should be still visible. So we can change the transformation in X and Y, the rotation, scan axis angle, the size of the pixels, so 20 by 20, and the depth for this specific field. So we're only working on this field 5. Let's say we want to put 40. And we see that now we change the grays because this is going to be a deeper field with respect to the others. So this is a very useful tool that allows us to further edit our our fields. In case we have a multiple field design with the laser, we can also change the power that we use to write different fields. So if we go to the power tab, we can see that there is different levels of power for each field in our design. Of course, this was not a GDS file, so it's a PNG. To avoid this gradient, you can just import a GDS, or you can also manually change the power for all the fields. And as part of the advanced tools, we also have a layout editor. In this case, we can have a view of all the layouts that we imported, and we can do further changes on these layouts. So we can move with respect to the origin position in the warm-up, change the rotation around the origin or the angle, and changing also geosystem. In this case we use the piezo center, but we can also use the warm-up, and also for transformation, so translation and rotation. We can also delete fields that we don't like. For example, we want to delete our last laser geometry that we splitted, and this will be removed from the layout editor and also from the session in the warm-up. So this is pretty much how you work with geometries which are larger than the piezo scanner range of motion, and also further videos in stitching, mix and match, and overlay will be more helpful to understand these functionalities.